So we continue with rates of change today, but we're talking about rates of change of polynomial functions. So these are those like snake-like shapes. They go up, they go down, they go up, they go down, that kind of thing, okay? They are continuous graphs. So the word poly means many or much. A non-constant polynomial function is a function with many terms in the form of a sub n, x to the n, and then a sub n minus 1, x to the n minus 1. So what this means in like that weird term is that the number on the front could be anything. This could be 1, this could be negative 17, whatever this is. This is a coefficient. It's called a leading coefficient. And it is attached to the variable with the highest exponent. So the degree, which is the highest exponent. It will not necessarily be in the order in which the highest is at the front. So you might be given an equation in which you've got like x to the second, and then later on you've got an x to the third or x to the fourth. So the goal would be to put it in order or to identify the highest exponent before you find out any characteristics of that function, okay? But this whole notation just means start with the highest exponent and work your way down, because a sub 0 would be something that does not have an exponent, a variable. So that would be the constant, like the constant would go last. That's what this notation means. Every n is getting decreased by 1. So highest exponent would be the first one, and then you would work your way down or go in decreasing degree format. That's all that means. It also says non-constant function. So what would a constant function look like? What's something constant? Constant meaning it doesn't change. Yes. That the slope wouldn't change, or your rate of change wouldn't change, right? So that's a horizontal line. So this is saying there's not going to be horizontal parts to it, like a piecewise function. Our functions are going to go up and down and continue on in both directions, okay? Because they won't be, unless they're restricted, unless their domain's restricted. But our initial polynomial functions will look something like that. These could be parabolas, these could be cubic functions, but they could also have many terms, because poly means many. Yeah.
So non-constant means there's like no horizontal lines.
Correct. Yep. So this is what you could see up on the top left. These are examples of what you might see, and then the bottom right, examples of what are not polynomial functions. So on the top left, they are smooth, they are rounded, and again, they are continuous, meaning you can start to draw and finish drawing without lifting your pencil from the paper or your stylus from your screen. Whereas on the right-hand side, these are not considered polynomial functions because they are piecewise. There's a start and stop to it, or it's disconnected, okay? Or sharp edges. No, those things you will not see in polynomial functions. God bless you. If it asks about the maximum amount of turning points, it can have at most n minus 1 turning points. So if my highest exponent is to the 5th, for example, then the max turning points is 4. 1 less than your highest exponent. Now, there can be less than that because some of these answers could be imaginary, like your roots could be imaginary, and then they wouldn't appear on your graph, which would eliminate 2 turns. But at most, they could be is 1 less than your highest exponent. So if I was just like looking at multiple choice graphs, and let's say I was looking at something that looked like this guy, every turning point means every max or min, right? So it's going down, then coming back up again, or decreasing, then changes to increasing. That's 1 turning point. Then it goes from increasing to decreasing. That's another turning point. Decreasing to increasing. That's another turning point. So because there's 3 turning points here, my exponent could be x to the 4th, okay, or anything higher than that. But it couldn't be x to the 3rd because if it was x to the 3rd, the max turning points would be 2. It couldn't be x to the 1st because the max turning points would be 0. It would be a line, right? Okay. Example 1 says, what's the leading term, the degree of the polynomial, and the leading coefficient? So start with the degree because that's how you determine the rest of it, right? What's the degree? 7. The highest exponent. So the degree highlights which term we're talking about when we say leading term. So my leading term is negative 3x to the 7th. The degree of the polynomial is that one's exponent. Thank you.
I'm sorry.
All right, degree of the polynomial is 7. And the leading coefficient is the term, or the the constant on the front of that, which would be what? Negative 3. Sign is important, okay? Sign goes with it. So vocab terms there. Leading term is the whole thing. Degree is the highest exponent. And the leading coefficient is the number on the front. All right, now we're going to talk about local or relative extrema. So we talked about this when we said, when we were talking about relative max or min. There could be more than one. It's the same thing as local. So local and relative mean the same thing. Sometimes on the AP, it calls it a local extrema. And sometimes on the AP, it calls it a relative extrema. You have to know those mean the same thing. A local max occurs anytime the graph changes from increasing to decreasing. We already know this. If my graph goes up and comes back down again, this we called a relative max. It is now called a local max. And a local min occurs every time the graph changes from decreasing to increasing. So as I come down and go back up again, this is called a local min. You can have multiple, right? Our graph can go up, come back down again, up, come get back down again. There can be more than one of these. This is not the same thing as an absolute max or min. And then this is important. An included endpoint of a polynomial with restricted domain may also have local or relative extrema. And what that means is if I take a polynomial, and let's say it's graphed, and it would continue on, but then I say restrict it from where your domain goes from negative infinity to 5. That means I'm literally going to cut it off there. I would ignore everything after it. And that would count as a local max. It's going up, okay? So if it ends or starts by getting cut off by a domain restriction, it is included in a max or a min. It's the highest point at that point. It's the highest on that area of the graph. So this graph would have a local max here, a local min here, and a local max here. So again, if it gets cut off, even though there's higher points on the left-hand side, this is a local max, not an absolute max. That would be different. Absolute, your AP refers to as global. So global means that is it. That is the highest point or that is the lowest point. It does not go up and down again higher than that. So an absolute or global min is the lowest point on the graph. An absolute or global max is the highest point on the graph. You can only have one of each of these. And your format will be a y equals. So if it just asks for the global max or the global min, you'll say y equals 2 or y equals negative 3. So if I had a graph again, a polynomial that started down, went up, started down, went up like this, those arrows point down and up, right? So there would be no global min or global max because the arrows will continue down or continue up. Now, if I stop this here, whether it's a domain restriction or it's physically stopped by the graph, then I would look for the highest point, which would be here. And that would be your global max. It's just a smidge higher, but it's definitely higher. So that would be your global max, not the other one. Global is absolute. Questions so far? Okay, so it will look something like this. Use a diagram to answer the questions. A says an absolute min of blank when x is blank. So my absolute min, if I look at this graph, What's the lowest point on this graph? It would go to negative infinity. So is there an absolute min or global min? No. You'll literally write does not exist. D-N-E, does not exist. How about an absolute max? Where's the highest point? Close. It's here, right? What's the y there? 7. So this coordinate point is 0, 7. When I ask for the max, it wants the value. That is your y. And then it says when x is, well, what was x at that point? 0. So instead of putting it in coordinate point format, we'll ask it like that. If it's asking the max, it's the y value. When it happens, it's the x value. All right, relative mins at. So it's telling you there could be more than one. What's the lowest point that's, well, every time it goes down, it comes back up again. So where's it going down and coming back up again? This coordinate point is negative 3, 3. So if it says at x equals, what's it looking for? Negative 3, okay? If it asked for the relative min and it said at x equal, or could be 3 at when x is negative 3 is what you could put there. Is there another local min? No, because that arrow is just going to keep going down. It doesn't come back up again. How about a local max? Here it's going to go, it's at a local max, right? That one's kind of restricted by your domain. And again, here it's going to go up and come back down again. So my x values are negative 6 and 0. Questions on that one? All right. Extrema between zeros. So this is where it will take, like, especially AP style questions. We'll give you a polynomial and it will give you information about zeros, and then it will ask you, does local extrema exist? Could it exist? If so, how many? That kind of thing. So it says if you have 2 zeros of a non-constant polynomial, then there must be at least one local extrema between them. So logically, if you think about this, if I have 2 zeros, my graph can go up and come back down again, and I would have one local max. My graph could go down and come back up again. I would have one local min. My graph could actually bounce off of here, but it would have to come back through here. So it's still one local max. It could bounce off of here, but it would still have to come back through here. So that would be one local max that way. It could bounce both directions, okay, off either side. Or it could even come up and come back down again because it didn't say those were your only zeros. And that's why it says at least. So it could actually physically cross through here and come back up again. And you have one of each. So if it said those were the only zeros, then my option is either that it's a local max above a local min, or it could bounce in between. I mean, or it could bounce but not hit the x-axis in between. But all of those cases require at least one local extrema between them. So this one says, let f of x be a polynomial with the given values. Are there any guaranteed extrema, and if so, state where they occur. And now it gives it to you in function notation. So f of 0 equals negative 1, f of 1 equals 0, and f of negative 3 equals 0 are simply coordinate points disguised in function form. So if I said take this and put it into a coordinate point, what would it be? 0, negative 1. The one side inside the parentheses is the x. What it's equal to is the y. If I said do the same thing here, it'd be 1, 0. And if I said do the same thing here, it'd be negative 3, 0. Now, hopefully you won't need to do this, but let's picture it by graphing it this time. 0, negative 1 means I have a coordinate point down here. 1, 0 means I have a coordinate point here. And negative 3, 0 means I have a coordinate point here. Now, based on the rule I just said before, between every pair of zeros, there has to be at least one local extrema, right? So which of these are zeros? Here and here, not the y-intercept, right? The y-intercept is there to throw you off. I gave you a 0 in the coordinate point, but that's a y-intercept. It has nothing to do with your zeros. So what has to happen in between negative 3 and 1? Does there have to be, is there guaranteed an extrema? Yes. Okay. So are there any? Yes. And where it has to occur is in between these two. So it is in between -3 and +1. Questions so far? All right, now we're talking about even degree absolute extrema. So if the polynomial has an even degree, then there's either an absolute max or an absolute min, because it takes on the characteristics of an x squared or an x to the 4th, which means the arrows are either pointing up or they're pointing down. If my arrows are always pointing up on the ends or always pointing down on the ends, that means I have to have at least an absolute max or an absolute min. My arrows are not pointing in opposite directions like an x cubed, okay? So if it's an exponent that is even, again, highest exponent, because you're talking about degree, highest exponent, and a positive leading coefficient, which we're going to talk about end behavior in a second, they are both pointing up, which means you're going to have an absolute minimum. So positive leading coefficient with an even degree means they're both pointing up, and you're going to have an absolute minimum. A negative leading coefficient would be like a parabola that points down. They're both going to point down, which means you're going to have an absolute maximum. So think about it in terms of a parabola. It could take on different shapes in between those arrows, but the end behavior or left and right arrows are always going to behave the same as it would on a quadratic. All right, this says, is there an absolute max or minimum of each function? So I'm looking for the degree and then the sign on its leading coefficient. If I go to A, what's the degree? 2, which is even, which means there has to be something. Now I go to the front term and it's positive, yes, which means this is a parabola that opens up. The arrows point up, which means it's going to have what? A max or a min? A minimum. Go to B. What's your highest exponent? 3. Now that's an odd power. In an odd power, they point in different directions. If it's positive, the right points up and the left points down. We're going to talk about that a little bit more when we get to end behavior. All we know here is it's odd. And if it's odd, we cannot guarantee. So it says, is there an absolute? And the answer's no. And then I go to C, and my degree is 4, which is even. Look at the leading coefficient. It is negative, which means the ends point down, which means this has good. So the answers, if it's even, highest exponent is even, it's going to be a yes. You just got to figure out if it's max or min. And if it's odd, it's going to be a no. All right, point of inflection. So I think I mentioned this the other day, but I don't know why it waits till now to say it, but this is where we say it. The point of inflection occurs at the input values where the rates of change from increasing to decreasing, which basically means it occurs when the graph changes from concave up to concave down, or vice versa, concave down to concave up. So if I have a graph and it's changing like this, then my point of inflection is where it changes from concave down to concave up. If it asked how many points of inflection or where is the point of inflection, that's how we identify it. I just literally draw. I draw my U's and my N's and see where it changes, and that is called your point of inflection. So it'd be where your rate of change changes from increasing to decreasing, or where your graph changes from concave up to concave down, or reverse. All right, so 5 says identify the point or points of inflection. All right, so if I were to zoom in on this first part of my graph takes on this shape. The second part of my graph takes on this U shape. The point where it changes is labeled as 2.33 and 8.29. So that is the point of inflection. If it went down again, obviously I would have another one. It could be one, it could be multiples. It could be none. If your graph is like just a parabola, then it always is concave up or concave down. All right, let's go through the homework questions, okay? So I will repost this, but if you want to check it. So 7, depending on what you picked, like what numbers did you pick, Reagan?
0, 1, and 2.
Okay, so when you plug in 0, you get -7. You plug in 1, you get -5. You plug in 2, you get -5 as well. So that's your f of, that's your initial value, right? So then if I want to find the rate of change, my first level rate of change, then I would do -5 minus a -5, which is 0. I want to do -5 minus a -7, which is 2. And then so that's your initial average rate of change. The rate of change of those would be 2 minus 0. Or, sorry, 0 minus 2. Say that again. How did I get to what? So your initial function, right, is what you're plugging in. -1, wait, you said 0, 1, 2. 0, 1, 2. When you plug it in, 0 gives you -7, 1 gives you -5, 2 gives you -5. Yeah, that's just your values though. That's not your rate of change. Your rate of change comes from the first difference after that. So -5 minus a -7 becomes -5 plus 7, which is 2. And -5 minus a -5 becomes -5 plus 5, which is 0. This is your average rate of change. This is asking for the rate of change of the average rate of change. So we have to go one more, and I would do 0 minus 2.
This was the completion rate.
Yeah, but these are like, to me, these are not something you shouldn't be able to do. AP Classroom I go light on, but these are like, anything you see on a PDF is totally test questionable.
Do you always do the second minus 8?
Yes, otherwise your interval is going to be different. So if you did it the other way, that's fine, but then your change in x has to be negative, and that gets confusing.
I got positive 2.
Yeah, so go the other way. So it's second minus first, third minus second. And I added in a fourth one here so that you could check your rate of change of your rate of change. So if I want to do 2 to check to make sure they're the same, then I need to add in a fourth point. So like I did -1. Good question. What's in front of the x is your average rate of change, right? So 21 is your average rate of change no matter what your input is. So my first would be 21, 21, 21, 21. That's my rate of change, right? That's my first difference. Then the rate of change of that would be 21 minus 21, 21 minus 21, 21 minus 21, which is 0. So you can save yourself time because on a linear function, your first rate of change or first difference is your slope. And then the second one, they're all going to be the same the first time. So the second one's always 0. You're welcome. All right, then 9 and 10, you had to find the pattern of your rate of change. Your rate of change was increasing for 9, which means it's concave down, and decreasing for 10, which means it's concave down. Did I say at 9 concave up? Sorry, 10 concave down. It's concave up because my rate of change is increasing. Right? There's my rates of change. And they're negative, but they are increasing. And then the second one, my rate of change, again, it's negative, but it's decreasing. So that would be concave down. Good? Okay. I will say some of the AP Classroom style questions were a little bit tricky because of the wording on it. So you got to get used to this stuff. Number 1 was just like an example that we did in class. So hopefully that one wasn't too bad. You got to pick 2 points. You got to find the slope. You got to use one of those points because it didn't give you the B this time to find the equation of your line. The equation of your line was y equals 4/3 x minus 6. And then you got to take, it wanted you to find f of 13. So take the 13, plug it in, and you would have gotten 34/3.
Can I just use y point slope intercept?
Yeah, but then you still have to plug in 13.
Correct.
Yes.
But I can still,
Sure. You can use point slope or slope intercept to find the equation of a line. but then you have to plug in the 13. All right, 2, and this is like a perfect example of what's going to happen on your AP exam. There's a million words there, and it's super confusing. You have to learn to start looking for some key terms. It says function f is defined for all real values of x. For a constant a, the average rate of change of f from x equals a to x equals a plus 1 is given by the expression of 2a plus 1. So what's important to notice is we're going from a to a plus 1. So in my increments, in my x values, are my x values getting bigger, are they getting smaller? If I go from a to a plus 1, bigger. So my input values are increasing, right? And that's important because if I did my rate of change and I did second minus first and I did second minus first of my x values, I know I'm going up by 1. If that said a minus 1, now my x values are decreasing. Does that make sense? Okay, so it's not giving you specific values, which means you have to understand the logic behind the expression. So a and then a plus 1 means we are increasing by 1 on every interval. And if that is 2a plus 1, that means that is also a bigger number every time. If I'm increasing a number and then I double it and I add 1 to it, it's going to continue to increase. So when you look at your options, it says the average rate of change is positive. Well, I don't know if it's positive because x could have been negative to begin with, which is the same for b. I don't know if it's positive. What I do know is it's getting bigger, which means they are increasing. And if they are increasing at a constant rate, then this says, could it be a line with positive slope? My rate of change is changing. If it was a line, what would be true about your rate of change? It would not change. It would be the same every time, right? A line has the same rate of change. Does that make sense? Your slope is the same no matter where you pick it. But this expression is saying it's not staying the same. It's changing every time. And if it's changing every time, then it has to have a different shape. It can't be a line, which in this case says could be, doesn't have to be, but could be a parabola that opens upward. If my rate of change is increasing, that means it's a U shape, which means it would be opening upward, okay? So this is a perfect example of how they take something that's like a simple concept and they overcomplicate it, and you have to figure out what they're saying. All right, 3 was back to like it gave you the average rate of change of the quadratic functions -4 on the interval from 0 to 2 and -1 on the interval from 2 to 4. What's the average rate of change on the interval from 6 to 8? Well, I know it's what's happening if my rate of change is going from -4 to -1. Is it increasing or decreasing? It's increasing. So if I look at those values that are listed, I can already eliminate some. But now I need to know, well, if they were negative, I could eliminate some, okay? Now I need to know what's the pattern. So if it's 0 from 2 is -4 and 2 to 4 is -1, then I can determine the rate of change there by doing -1 minus a -4, which is 3. And that tells me I have to go up again by 3. I have to go up again by 3. That's only because it's quadratic, though. If it wasn't quadratic, you couldn't do that. But quadratic, we know the second difference is the same. So you have to figure out the rate of change of your average rates of change or your second difference, and then use that pattern to find the next one. All right, 4. It said an object is moving in a straight line from the starting point. The distance in meters from the starting point at selected times in seconds is given by the table. If the pattern is consistent, which of the following statements about the rate of change of the rates of change of distance over time is true? Most important part is it said straight line. If it's a straight line, what's true about my rate of change? It's constant. So the rate of change of the rates of change is going to be not constant, 0. I mean, technically constant, yes, but 0 specifically. So rate of change of average rate of change of lines equals 0. Because we stopped at 5. So 5, it said, first of all, if you look at the choices, and I always do that, like look at the choices and look what it's looking for first. read your question, but then go there. It says linear function or quadratic function. Those are the first two things. So if I have a rate of change and it's a linear function, let's say, what do I expect to happen that first rate of change or the first difference? If it's linear. What is true about your rate of change if it's a line? What's true about your slope if it's a line? It's the same no matter what, yes? So if I find a rate of change from that box, it should be the same. The first rate of change, which is your first difference, should be the same for a line. As soon as it wasn't, like as soon as you found the rate of change and it was not, that means you rule out A and B. Then the second part says that the quadratic function, because of the rate of change, it's quadratic because of the rate of change of the rate of change. So now if I go to the second difference there, it was the same. That means it's quadratic. And we will spend a whole section on how to classify these because we will continue to keep adding to this list. But it's important to understand that that means it's quadratic. Then it says that the intervals of the rates of change over the consecutive equal length intervals in the table can be described by 2x. Well, or 2x plus 1. If you look at, this is your rate of change. So if you look at your rate of change and you want to get a line going there, you would find it with those coordinate points. And the rate of change there was -2 no matter what. But was it just -2? Or if you compare it to your initial one, was it more than that? And that's what it took. The actual rates of change would have produced an equation that was 2x plus 1. So you could literally use your rates of change to create a linear equation. All right, but I said I want to make sure that we highlight this. The notation on 6 is important. So if you're on anything else, you need to give me your attention. The notation on this question is like it literally is saying rate of change and average rate of change, but without using words. If it says g of x is equal to f of x plus 1 minus f of x, that is saying the rate of change. So this is your average rate of change. This is your first difference because it's saying f of x plus 1, which would be the second term, minus f of x, which would be the first term. So this is its way of saying rate of change without using the words. Then it says h of x is g of x plus 1 minus g of x. Well, g of x plus 1 would be this guy with the second term and then that guy with the first term. So that is your rate of change of your average rate of change. That is your second difference. So if the second difference is -6, 1, it can't be a line because if the second difference should be 0. If it's -6, it means that it's decreasing. So your rate of change is not only negative, which means this one is negative, which means the original one is decreasing. And this one has a decreasing rate of change, which means it's concave down. So it's a negative value and also decreasing. Each time you're going on the rate of change of the rate of change, so second difference, it is going down by 6. So your rate of change is decreasing, which means it would be concave down. Not negative slope. The initial one might have negative slope, but the rate of change of it, which is the G, does not.